Space black hole. A black hole is a region in space where the gravitational pull is so strong that nothing, not even light, can escape from it. Massive stars collapse under their own gravity. They are mysterious and fascinating objects that continue to be a subject of scientific research and exploration. If you have specific questions about black holes or would like more information, please feel free to ask. Certainly. Here's some comprehensive information about black holes. Formation. Black holes are formed from the remnants of massive stars that have exhausted their nuclear fuel. When such a star can no longer support its own gravitational pressure, it collapses in on itself, forming a black hole. Structure. A black hole has three main components. Singularity. The core of a black hole is the singularity, a point where gravity is infinitely strong and where the laws of physics as we understand them break down. Event horizon. This is the boundary around a black hole beyond which nothing can escape, not even light. It is often called the point of no return. Accretion disk. Some black holes, especially those in binary systems, have a swirling disk of matter, called an accretion disk, around them. This material is gradually pulled into the black hole. Types of black holes. There are primarily three types of black holes. Stellar mass black holes. These form from the remnants of massive stars and typically have a mass between a few to several times that of our Sun. Intermediate mass black holes. These are more massive than stellar mass black holes but smaller than supermassive black holes. Their formation process is still a subject of study. Supermassive black holes. Found at the centers of most galaxies, these black holes have millions to billions of times the mass of our Sun. Their origin is not completely understood. Detection. Black holes are usually detected indirectly through their gravitational effects on nearby objects, or by observing the radiation emitted from the hot accretion disks around them. Technologies like the Event Horizon Telescope have allowed us to capture images of the silhouette of a supermassive black hole at the center of the galaxy M87. Hawking radiation. Theoretical physicist Stephen Hawking proposed that black holes can emit a type of radiation called Hawking radiation, which causes them to slowly lose mass over time. This process has profound implications for the long-term fate of black holes. Black hole paradoxes. Black holes are known for their intriguing paradoxes, such as the information paradox, which raises questions about what happens to information that falls into a black hole. Astrophysical role. Black holes play a crucial role in the universe's evolution. They influence the dynamics of galaxies, participate in the formation of stars, and can produce powerful phenomena like gamma-ray bursts when they merge. Scientific exploration. The study of black holes remains an active area of research, and scientists continue to learn more about their properties and behaviors through observations and simulations. Black holes are some of the most enigmatic objects in the cosmos, and our understanding of them continues to evolve as technology and our knowledge of astrophysics advances. If you have more specific questions or want to know more about a particular aspect of black holes, feel free to ask. Free research preview. ChatGPT may produce inaccurate information about people, places, or facts.